Hey everyone, it's Alex, and today we're going to talk about day 4 of Advent of Code in Fourth. So this is a little bit delayed. I haven't been able to do these every day, but hopefully I catch up and get to the ones that I can and maybe fill in the rest after the end of the month. So day 4, we have a series of scorecards, and essentially you have winning numbers here and then all of your numbers, and you have to see which of your numbers are winning numbers and then come up with a point system for each card and then sum all of the points for each card. And then in part 2 you use the point system, but instead of just saving the points, you use it to add copies to the next card, and then that card adds copies based on its number of copies and so on. Anyway, you can read the problem if you're not familiar with it. But essentially, I tried to do things a little bit differently this time. One of the things is I tried to make the solution a little bit more clear. So I tried to make the words like actually match what the problem asks. But this is similar to day 2, where we actually use the fourth interpreter to solve the problem. So if you go back to the the problem here, you can see again, this is a problem that sort of looks like fourth. You have card, you have this pipe, and then you have a bunch of numbers. And so as long as you can operate on the numbers on the stack, you can solve the problem. So here you can see I define card, and then I define pipe. And what this does is once you define card and once you define pipe, you can read the input here and then solve the problem. So our solution is going to solve parts 1 and 2. In both parts, we need a check wins word. And this tells you how many wins you got in the scorecard. And the way that we do this is we use, so the first thing that we do is we use scount. So this is maybe a little bit dicey or hacky, but this is a word that tells you the number of items that are on the stack. And so once we read the input, we're going to have a bunch of items on the stack. And then while those items are on the stack, we're going to loop to continue consuming each number on the stack. This is a little bit weird and was the source of an issue that was really hard to debug. And so this might be me being a little bit aggressive and trying to do a solution where I just use the fourth interpreter. But I'm not super unhappy with my approach here. So the second part of check wins is winning buff. And so this is where we basically check if the item is a winner, and if so, we add to the number of wins, and then we return the number of wins. And the way that we set winning buff is done through the pipe operator. And so the pipe operator again uses scount to iterate over all of the items on the stack, and then we set the buffer for that number to 1. So essentially, we create an array that has 100 elements, and each element in that array is a Boolean flag that we set to 1 if that number was a winning number. So the pipe will set the buffer that has all the winning numbers, and then check wins will check each number to see if when you index the array according to that number, is it a 1? If so, add to the result and add to the number of wins. So once we have pipe and check wins, that's the way that we get the number of wins for each card. And so that is for part 1. What we do is essentially a points, which is just 2 to the n minus 1, and then add to a point total, and then we return the point total. And for part 2, we do the add copies function. Add copies will basically, this is not the most beautiful code in the world, basically we have a running index of the current card, and as we iterate, we increment that index, and then we add a number of copies equal to the number of copies plus 1 of the card, and then we do that a number of times equal to n. So if you aren't familiar with this problem, this might be confusing. I encourage you to try it yourself, and then maybe this makes a little bit more sense. So we have a couple of utils here. One of them is sum, and so what we do is we use our array of all the number of copies, and we sum that up together, and that's the answer for part 2. And you can see if I run for both part 1 and part 2, there's the answers. So 2 other things that I want to talk about is I used skip for the last one, but I modified it a little bit to be skip through. This one takes a character and then it goes up to that character and then consumes that character. And that's how we get rid of the number in the input. The second thing is this array. So Dusk OS has an array construct, and so I thought about using that, but that's more about like a list that you insert into rather than just a fixed allocated array where we store booleans. And so this is a traditional fourth array where you use the does binding word, and this way you allocate a set of memory, and then you define a runtime for the word that you use that you just allocated as an array, and then the runtime gets an index of the array. So in other words, I define an array, for example, the winning buff array with 100 array winning buff. So this creates an array of 100 elements. And then if I want to index the array, I do I winning buff. And what that will do is it will do the does runtime behavior of the word, which basically just adds the cell. So in other words, the array is a pointer to itself with a runtime behavior of adding an integer to that pointer. And so I can index the array by doing 1 name of array, 2 name of array, and that'll give the associated index. So this is the way that this is how I create the arrays for winning buff, as well as the array for card copies, and then I sum the array with sum. And then one comment here is this is a little bit wasteful because I'm creating a 32-bit array. So each item in the array is a 32-bit integer, but I'm only storing a Boolean value. So I could have modified this to be an 8-bit array, but I just decided to keep everything 32-bit just for simplicity. So this one was a little bit more challenging. I had a number of issues with my implementation, but I think I'm relatively happy with what I came up with. In the description, you'll find a link to the repository that has all of my solutions. If you have any questions, feel free to leave them in the comments. And don't forget to like this video if you enjoyed it, and subscribe if you want to hear more Advent of Code in Forth.